Okay, this is the fourth and final vodcast for the C work. It's going to cover moles, particles, and volume. Calculations. Beforehand, we've just done moles and mass. You really need a calculator handy along with a periodic table too. And, preferably you want the calculator that you'll typically be using in class. So, just a refresher. 1 mole is 6.02 times 10 to the 23rd things. Again, that's atoms, molecules, formula units, ions, etc. We calculate the molar mass by adding the masses of the individual elements up off the periodic table. And so this is the same as saying 1 mole of water is 18.02 grams. Now, on your calculator, I want you to take your calculator and find the exponent key. It generally looks like EXP or an EE, sometimes above the key, sometimes actually on the key. So take a moment, that's the key you're looking for on your calculator. If you're using the calculators I have in class, I included some pictures here. So this is the one style of calculator. It's circled here in green. That's the EXP key that you're looking for. You might see these keys that I've circled in red, the carat and then the 10x. I don't want you using those. So if you were to enter 6.02 times 10 to the 23rd, if you want to put that in on your calculator, you would do 6.02, use your exponent key, and then put in 23. And that's what will get you on the screen. You do not actually want to enter in the times 10. Okay? So don't actually key this in, this times 10. That's what your exponent key means. So that E means the same as times 10. If you're using a Texas Instrument graphing calculator, okay, again, stay away from the keys that I've circled in red, not the 10x, not the carat. Here's your EE key. So for this one, you need to use the second button and then the EE. So if you were to enter it, 6.02, and then you'd use the second key, and then hit the comma key, which has the EE, so the comma with the EE on top, and then you would enter 23 to enter 6.02 times 10 to the 23rd. Okay, here's the other style of calculator I have in class. Again, avoid the key circle in red. There's your blue EE key. You're going to have to use the second button just like on the other Texas Instruments. So 6.02, your second, and then your EE key, and then enter your 23. On no calculator whatsoever, okay, even if you have one of the ones that I am not showing you pictures of, you will never actually type times 10 on your calculator. Okay, you will always use some form of an exponent key. If you actually write times 10 and then try and use the carat key or something like that, you're going to get the wrong answer about half the time. So let's work some practice problems here. Here's our first one. How many molecules of H2O are there in 6.54 moles of H2O? Now, these work out the same exact way as the mass ones that we used. Okay, first I want you to put a circle around what you're looking for and put a box around what you are given. Okay, so circle what you're looking for, put a box around what you know. Now, the problems are going to set up exactly the same way. What we're looking for is X. So I'm going to fill in X molecules of H2O. And underneath it, I'm going to put what I'm given, 6.54 moles of H2O. On the other side, for the units, okay, they're going to carry over molecules there, moles on the bottom, underneath my ratio line. Okay, now there's really no abbreviation for molecules. You're just going to have to try and tough it up. You can't write M because that's meters. MOL or MOLE is already moles, so just suck it up, write molecules. Now, 1 mole is 6.02 times 10 to the 23rd molecules. We already have that relationship. That's one of the first things you guys learned in this unit after sig figs. So next to moles goes the 1. Next to molecules, because that's what it is here, I'm going to fill in the 6.02 times 10 to the 23rd. Just like that. And just like before, you're going to cross multiply and solve for x. And that's what you get. X molecules times 1 mole equals 64 or 6.43 times 6.02 exponent 23. We want to get x by itself, so we have to cancel out moles. That's going to have these moles cancel. And in your calculator, you're going to do 6.43 times 6.02 exponent 23. And this is what you should get on your calculator. It might use an E for the times 10, but on your paper, you're going to put times 10 instead of an E. You're going to look at your sig figs. 6.43 is 3 sig figs. 6.02 is 3 sig figs. And your 1 is infinite. So I want to round this to 3 significant figures. I take those numbers, I look to the next one to round, and that says to round up. So 3.94 times 10 to the 24th molecules of H2O. Okay? So really, there's not much new here in terms of problem solving. Instead of using grams off the periodic table, now we're using molecules and the 6.02 times 10 to the 23rd. It also works the same way for atoms or formula units. So here, how many moles of carbon dioxide is 7.850 times 10 to the 22nd molecules? So we circle the number of moles. That's what we're looking for. How many moles? We put a box around what we're given, 7.850 times 10 to the 22nd. Okay. What we're looking for is X. I have X moles of CO2, and what I'm provided is 7.850 times 10 to the 22nd molecules. When you're going to set up your units on the other side, moles on top, here's molecules, molecules on the bottom. Okay? Now ask yourself, in 1 mole, because everything relates back to 1 mole, how many molecules are there? 6.02 times 10 to the 23rd. So in 1 mole, 6.02 times 10 to the 23rd. Cross multiply, solve for X. Okay. So here's how your problem's set up. X moles times 6.02 exponent 23 equals 7.850 times 10 to the 22nd times 1 mole. We want to get X by itself, so you need to divide by Avogadro's number there. The 6.02 times 10 to the 23rd. That helps those cancel out. That's going to have these units cancel out. Now, here's the true test as to whether or not you're using your calculator properly. If you get something that says to like the 45th, you're using your calculator wrong. Okay? So try this on your calculator, and this is what you should get. Again, if you got 1.3 times 10 to the 45th or 46, something like that, see me with your calculator and I will help you. Alright, and we are looking for sig figs. Here's 4. This one's infinite. This one is 3 sig figs. So I'm going to go with my lowest, which is 3 sig figs. Remember, leading zeros don't count. We just keep them as placeholders. So I take the first 3 significant figures. I look to the next number to round. It's a 3. So nothing changes there. And it's 0.130 moles of CO2. Alright, one more of this type you should set up. How many moles is 8.8 times 10 to the 21st formula units of aluminum chloride? Now, this one's called formula units because it has ionic bonds. It has a metal, aluminum, with a non-metal. So we can't call them molecules, we have to call them formula units at this point. It does not change at all how we set up the problem. We are given formula units to start, 8.8 times 10 to the 21st, and we are looking for number of moles. So what you're looking for is x moles of aluminum chloride. What you know goes underneath, 8.8 times 10 to the 21st. Okay, the matching units go on the other side. Now in 1 mole, how many formula units are there? 6.02 times 10 to the 23rd. It does not matter what compound we're talking about. Okay, it's going to be 6.02 times 10 to the 23rd. Cross multiply, solve for x. Here's the problem set up. We want to get x by itself, so yet again, you need to divide by Avogadro's number to get these things to cancel out. Now your formula units here will cancel out. Calculate it in your calculator. Again, if you get something times 10 to the 40 something or other, you're using your calculator improperly. You're doing it wrong. Come see me and I'll help you with the exponent key. This on the screen is the answer you should be getting. Now, look at for sig figs. Here's 2 sig figs. One is infinite. This one is 3 sig figs. So I need 2 sig figs. Leading zeros don't count. I take the first 2 numbers past that. So the zeros and then the 1, 4. I look to the next number to round. It's a 6. So I will round up. And that's what I get. 0.015 moles of aluminum chloride. That's your final answer. Okay, so that's solving for some sort of representative particles. Solving for volume. If we're doing it, we're going to be doing it with gases, not liquids at this point. Gases are very difficult to get the mass of. So sometimes we need to know how many moles of a gas we have. So 2 things are going to affect the volume of a gas: the temperature of the gas and the pressure of a gas. Now, second semester, we're going to do a whole unit on gases and talk more about temperature and pressure. But right now, I'm just going to give you the bare basics so you can solve the problems that you have here in this unit. Now, we're going to assume that all the problems are worked at standard temperature and pressure. And standard temperature is 0 degrees Celsius and standard pressure is 1 atmosphere. So here's my T and my P. Okay? It gets abbreviated as STP. So when you see that in a problem, that essentially is telling you 0 degrees Celsius, 1 atmosphere of pressure. That's the atmosphere is a unit of pressure. Okay? It's essentially saying conditions are normal, proceed the way you should. Okay? Conditions won't ever not be normal. Okay, so even if they forget to mention it in the problem, which sometimes I do, you can just safely assume that STP conditions are around. Now, when you are at standard temperature and pressure, 1 mole of gas will occupy 22.4 liters. This is called the molar volume, okay, or the volume of 1 mole of a gas at STP. So 1 mole equals 22.4 liters of any gas as long as it's at standard temperature and pressure. So solving these for the problems, same process, okay? You're going to love these because these are easy. Okay, what is the volume of 4.59 moles of CO2 gas at STP? So what we're looking for is the volume. What we're given to solve, the moles. Set it up the same way we've been practicing. We're looking for volume, so X liters, that's our units of volume, divided by what I'm provided, 4.59 moles. Now, the units carry over, liters over here on top, this is moles on the bottom, so moles on the bottom for your ratio. Now, you need some relationship between moles and liters. Well, since we're at STP, we know a relationship between moles and liters. 1 mole is 22.4 liters at STP. So that's what I'm going to fill in. 1 mole, 22.4 liters. Cross multiply, solve for X. I hope by now you're seeing a pattern in these problems. Okay, it's always going to be the same thing. Okay, we want to get X by itself, so we need to cancel the 1 mole. That's going to cancel the moles of CO2 there. And when you multiply 4.59 times 22.4 liters, this is what you get, 102.186. Check our sig figs. I've got 3 sig figs, 3 sig figs, infinite. So I'm going to round my answer to 3 sig figs. That means I get to keep the 102. I look to the next number to round. It's an 8. 8's round up. So 103 liters of carbon dioxide gas. That's all there is to it. All right, how many moles is 5.67 liters of oxygen O2 at STP? Okay, circle what you're given, put a box around what you know, and then start to set up the problem. It would be nice here if you paused and tried to set up one of these on your own. So moles is what I'm looking for. So there's my X. I'm provided 5.67 liters. So the units need to be the same on the other side. We're at STP, so 1 mole of a gas is 22.4 liters. And we cross multiply and solve for X. We need to get X by itself. So divide by 22.4 liters to get X by itself. Those cancel out. Okay, liters over here will cancel out. And I'm left with 5.67 times 1, which is 5.67, divided by 22.4. That's what your calculator spits out. Look for your significant figure. Here's 3, infinite, and 3. So you're going to round to 3 significant figures. Leading zeros don't count. So we just take the first 3 numbers, look to the next one to round. It's a 1. We don't do anything with ones, and it becomes 0.253 moles of O2. Now, everything we've done so far has related back to the mole. And so this is called the mole roadmap. Okay, so here's the relationships that you've been working on the last few days. We have volume, which we just looked at, and as long as you're at STP, 1 mole is 22.4 liters. Okay, 1 mole is 6.02 times 10 to the 23rd particles. That's atoms, molecules, formula units. 1 mole can be measured in grams, the mass in grams, and that means we need to add up the molar mass off the periodic table. So this shows you how these all relate. Now, because everything has moles in common, that means I can take moles and mass and figure out volume, and I can take mass and figure out particles, or I can take particles and figure out volume, and vice versa, because we have that mole relationship to go between. So we're going to try a couple of those problems right now. So converting between other units. How many carbon atoms are in a 50 carat diamond that's pure carbon? 50 carats is the same as 10 grams. Okay? So what are we looking for? We are looking for the carbon atoms. What are we given to solve? Well, you're given 2 numbers, 50 carats, right here, and 10 grams. Now you're told 50 carats is the same as 10 grams. So essentially 50 carats here, this number is extra information. We're given 10 grams to help us solve. So we set it up the same way we always set it up. What we're looking for is X atoms of carbon. What we're given 10 grams of carbon. Now on this side, same units, atoms. And on the bottom, same units, grams. Okay? We do need a relationship between atoms and grams, and we have one. If we're looking at carbon and we count out 1 mole of carbon atoms, well, if we need 1 mole of carbon atoms, that's 6.02 times 10 to the 23rd. Which has a mass of 12.01 grams. So next to atoms, 6.02 times 10 to the 23rd. If I count all those out, 602 sextillion, I would get 12.01 grams. Cross multiply, solve for X. Okay? Need to get X by itself. divide by 12.01 on both sides. They cancel out. Here, grams will cancel. And I have 10 times 6.02 times 10 to the 23rd divided by 12.01. So you're going to do that on your calculator. Remember, you are looking for your exponent key. Don't do times 10. Use your exponent key for that function. Notice also in this problem we didn't have a 1. And that's because we don't have moles in this problem. This problem didn't have moles at all. We're kind of relating everything, one thing to another, and we skipped the mole step. So once you solve this on your calculator, that's what it works out to. You want to check your sig figs. Here's 3, here's 3, here's 4. So 3 is my least number of sig figs. I get to keep the first 3 numbers. That's those. 5.01, look to the next number around. It's a 2. Don't do anything there. Keep your exponent. 5.01 times 10 to the 23rd atoms of carbon. That's all there is to it. Once you understand the problem-solving process, you can solve anything, okay? We are going to be using the same process in the second semester. This is not going to go away. I told you this at the beginning of the unit. This is one of the biggest concepts of the whole semester. Well, the whole year, the whole idea behind chemistry. All right, what's the mass in grams of 1 atom of mercury? So we're given 1 atom, we're asked for the mass in grams. Okay, so X grams of Hg for mercury. We are given 1 atom to start. Now that's exactly 1 atom. That's why I don't have any decimal point there. Okay, because you can't have half an atom. You either got a whole atom or you don't. Same units on the other side, grams and atoms. Okay, now I don't have moles, so I'm not going to put in a 1 there. But I can look up grams off the periodic table, and for mercury that's 259. My cat stepped on it there, so that's why the screen disappeared. So for mercury that's 200.59 grams of Hg, and atoms is Avogadro's number, 6.02 times 10 to the 23rd. Cross multiply, solve for X. I don't know about you. You're probably getting tired of hearing that. But it's the same process over and over again. We got to get X by itself. So you got to divide by Avogadro's number. So that cancels out on the left. And then on the right, 1 atom times 200.59 grams divided by 6.02 exponent 23. Solve that on your calculator, and that's what you should get. Okay, think about it. It's 1 atom. That's going to be a very tiny number. There's 21 zeros in front of that 3 if you didn't write it in scientific notation. Now I did say this 1 atom was infinite. This one here is 5 sig figs, and this is 3. So you're going to round your answer. Oh, I have a typo there. Not to 1 sig fig, but to 3 sig figs, okay? So we're going to ignore what's going to pop up next. We're going to take the first 3 numbers. I think I was looking at that 1, okay? And the next number right there is a 2, so I don't do anything for the rounding, and we're going to ignore that answer. Our answer is 3.33 times 10 to the negative 22nd grams of Hg, right? It's not 1 sig fig, it's 3 sig figs. All right, last one. What's the volume of 8.8 grams of methane gas at STP? Methane is CH4. So again, I recommend you pause, try and set this one up on your own. Okay, they're not that hard. Given 8.8 grams, we're looking for volume. Volume's measured in liters. We're at STP, so that's going to help us out. So since we're looking for liters, X liters divided by 8.8 grams. Same units on the other side. Bring these over here. Bring these units over, well, over here. Right? Bring those around. We need a relationship between liters and grams. Now, since we're at STP, like we always will be, you can just put in 22.4 liters for STP. For the liters right here, 22.4. And grams, it's always going to come off the periodic table. So add up a carbon and 4 hydrogens, get the molar mass of methane, and put that number in there. So 22.4 liters, 16.05 grams for the methane. Cross multiply, solve for X. Get X by itself. Grams cancels. 8.8 times 22.4 divided by 16.05. Check our sig figs. Here's 2, here's 3, and here's 4. So I can only keep 2 sig figs. I look to the next number to round, and I have 12 liters of carbon. Okay? So that's all there is to it. On your worksheet for this one, I do put them out in sections. So on some of them, you know you're just doing Avogadro's number. On some of them, you know you're just doing liters, volume. And then in the next section, you're doing ones that don't have moles. And then your last worksheet for the C work is just all the different types of problems all mixed up.